We often speak about artificial intelligence as if it's a digital brain capable of thinking. But in reality, AI does not know anything. It is not a conscious entity, yet it can outmaneuver humans at chess, diagnose diseases, and write coherent essays. To understand how this is possible, we have to look past the metaphor of human intelligence and see AI for what it truly is, a mathematical prediction engine. This mathematical engine is what powers AI's impressive capabilities in areas like complex strategy games, medical diagnosis, and creative writing. To really grasp modern AI, we must move beyond the old way of thinking about computer logic. Most people imagine AI as a series of complex rules written by programmers, an endless list of if this, then that instructions. Under this old model, a computer could only do what a human explicitly told it to do. However, the world is simply too messy for a list of rules. You cannot write a rule for every possible way a human might draw the letter A, or every way a cat might look in a photograph. The crucial shift is moving from following rigid instructions to learning from flexible patterns. The foundation of this pattern-based learning is the neural network. To understand how AI works today, we must look at a process called machine learning, specifically neural networks. Imagine a massive wall of thousands of tiny light switches arranged in layers. The first layer is the input. The final layer is the output. In between are the hidden layers. When you feed an image of a handwritten number 5 into the input layer, the image is broken down into tiny pixels. Initially, the switches are set at random. The AI might guess that the 5 is actually an 8. At this point, the system is told it is wrong. This is the crucial part. The system then works backward, adjusting the weight or sensitivity of every switch that contributed to the wrong answer. Now that we understand how the network learns, let's look at how this mathematical prediction engine operates in the real world. It isn't seeing a number, it's identifying a statistical probability. This is precisely why AI requires massive amounts of data. A practical example is your email's spam filter. It doesn't just look for specific bad words. Instead, it analyzes millions of emails, noticing patterns. Finally, look at generative AI, like chatbots. These models do not think of an answer. They predict, one word at a time, the most statistically probable next word in the sequence. This shift from, quote, logic-based computing to pattern-based computing fundamentally changes our relationship with technology. This allows us to solve problems that were previously too complex for rigid rules, such as predicting how proteins fold in biology. However, because these systems rely on patterns, they are only as good as the data they are fed. If the data is biased or incomplete, the AI will perfectly replicate those flaws. Understanding that AI is a mirror of data, rather than an independent mind, is essential for using it responsibly. It is not a machine that thinks, but a mathematical system that turns massive amounts of data into highly accurate predictions. Thank you for watching. Subscribe to my channel Quantum Brief for more updates.